So we're going to do theoretical calculation for figure 1. We want to calculate the DC value of VB, VE, VC and IE, and also to do AC analysis to calculate V in, V out, and also voltage gain. So this is the circuit that we after we remove the unnecessary part. So we got this equivalent circuit. So first of all, we need to find RTH. RTH we can get by parallel the R1 and R2. Therefore, we get 7.67 kilo ohm. After that, we need to find VTH. VTH is from the VCC multiplied by voltage divider R2 over R1 plus R2. By then, we will get VTH equals to 2.33. In this case, VTH is equivalent to VR2 and also equivalent with VB. To find VE, we will do equation VBE equals to VE minus VE. As we know, VBE is 0.7. So we derive back VE equals to 2.33 minus 0.7, and the answer is 1.63. To find IE, we just by using Ohm's law, V over R. So to get IE, VE over RE, 1.63 divided or over 1 kilo ohm, and then we will get IE equals to 1.63 milliampere. Next one, we want to find VC. So if you look at the circuit that has been drawn, to find VC, VC is equals to VCE equals to VC minus VE. To find VCE, we do Kirchhoff law. Negative VCC plus ICRC plus VCE plus IERE equals to 0. You can see that in the picture. So VCE equals to 10 from the VCC minus 1.63 milliampere multiplied by 4 kilo ohms, and VCE we will get 3.48 volt. So after we get VCE, we can find VC. VC is equals to 3.48 from the VCE and plus with the VE, which is we get by the Ohm's law up there, 1.63. So our VC is 5.11 volt. From the figure 1, we redraw the circuit to do AC analysis equivalent. Therefore, we got this circuit. RE equals to 26 millivolt divided by IE. 26 milli divided by 1.63 milli, then we can get 15.95 ohms. To find VO, VO is equals to negative IO multiplied by ZO. ZO in this figure, which is RC, 3 kilo ohm. VO also equals to negative beta IB RC. V in, if you look at the drawing, V in is equal to I in Z in. Z in we can get by parallel the R1, R2 and beta RE. Therefore, the V in, equation V in is IB multiplied by beta RE. To get voltage gain equals to VO over V in. We do some math here and then we can get RC negative RC divided by RE. Then we can get negative 188.09. So V peak to peak we can get here is 50 millivolt. So V peak will be equivalent to V in. So 50 millivolt divided by 2, we can get 25 millivolt. V out is equals to voltage gain multiplied by the V in. Then we can get V out equals to negative 4.7 volt. Then we move to figure 2. So figure 2 is the same as figure 1. We just want to find the same thing but different circuit. We do DC analysis for the figure 2. Same as the figure 1. First we need to find RTH. RTH we can get by R1 multiplied by R2 divided by R1 plus R2. And then we can get the 7.674 kilo ohms. They ask for VB. VB equals to VCC multiplied by R2 divided by R1 plus R2. VCC, which is 10, multiplied by 10k over 43k. We can get 2.33 volt. The question asks for VE and IE, also VC. VE is in the equation of VBE. VBE equals to VB minus VE. VBE, as you know, is 0.7. So VE equals to 2.33 from the VB minus 0.7. We can get the 1.63 volt. To find IE, we use Ohm's law. I equals to V over R. So IE is equals to 1.63 milliampere. Therefore, the VC we get here is 10 volt. So for the question B, the question asks for V in, V out and also voltage gain. So for figure 2, we redraw the AC equivalent circuit. We get like this. So as you know, the equation for V in is equal to I in multiplied by Z in. I in here, which is IB, and Z in is beta RE. RE is equals to 26 millivolt divided by IE. So we get here RE is equals to 16.995. For V out, its equation is negative IO multiplied by ZO. If you look at the drawing picture, you can see why it become negative IO. Negative IO is equivalent to beta IB. So for voltage gain, the formula is V out over V in. Here we put all the value we can get. Negative 1 kilo divided by 15.95. Then we get the voltage gain equals to negative 62.70. Here V in is equal to Vp, and also equals to 1 Vpp over 2 equals to 1.5 Vp. To get Vo, we derive the equation and we can get 0.5 multiplied by negative 62.70, and we get the V out value negative 31.35 volt.
Hello, I'm gonna show you how to find the DC and AC amplifier for BJT for figure 1. So this is the circuit looks like. First thing first, we are gonna find the DC values. So how to find the DC values? Just click this symbol right here, and I'm gonna find VB first. So this is VB. How to find VB? VB is equal to VR2, R2 resistor. And then I'm going to find RC value, which is at here. So I'm going to okay. And second is RE, which is VE. I'm going to find VE. VE is freezing word, right? Alright. And lastly, we are going to find IE. So just click symbol A because it is an ampere for DC. So click right here E. So this is DC amplifier looks like. This is how to read. So how I'm gonna read it, I'm gonna click this run, and this is how it looks like. So to read this, first we can click the top of the V value, which is 2.23 volt for VB, and then okay, we can see at RC value, and you can see at is the value is not stopping. You can read this value. So the another option is you can read this because we are gonna take a rate for VDC. So this is 5.37 volt, and VE is 1.56, and AE is 1.56 milliampere. So that's how we are gonna calculate for DC values. And next is we are gonna calculate, we are gonna simulate for LC value. So how is we are gonna use oscilloscope. So just left click, and then this is how it's gonna be. So at first there is no this. So at first this is how it looks like. The wave is not gonna stop, and it's gonna run. So how to read this value? Just click pause, and then the wave is gonna stop. Right? It's the wave is stopped. So you just select here, and yes, this is how it looks like. And then just click here, and it's like here, and this the blue one is and red wire is at A channel, which is you can see A channel is using, and B is V out for positive. And negative, we're gonna connect to the ground. And yeah, so how to we calculate? So this is V out. We are gonna read for V out because V out is V channel. So this is so I'm gonna here, and this is for V in. Look here, for example. And how to calculate? Oh, my mistake. How to read the value is this is at T1. So we can see this is one, this is two. So one is T1 and two is T2. So at one, this is right? So this which means it's channel A. So we are gonna go to T1 and channel A, and this is representing 24.5 24.945 millivolt. And for the T2, we are it's gonna be. So here you put the value. Negative 3.7 volt. So that's the value for AC amplifier. So the next one is we are gonna calculate for figure 2. So this is figure 1. And figure 2 is the circuit is like this. So I already put the voltage DC and AC to calculate this. And I'm just right now I'm just gonna so figure 1 I'm gonna stop this, and then I'm gonna write this figure 2. So I'm gonna run, and this is the same as before. We just need to read the V value or VC. There is two options to read this, and you can see the value is 2.23 volt and or 2.4. And then for this is for BB, and VC is 10 volt because there is no RC value, and VE is 1.57, and lastly IE is 1.57 milliampere. So that's the value. And we'll continue for LC to find the reading for LC amplifier. So just split, and this is the oscilloscope. Oh, this is not still not running, so I'm gonna click this run. So this is how it looks. So I'm just gonna pause, and then I'm gonna click the reverse because it's more easy to read. And I'm gonna slide here, like slide this, and then yes, this is how we are gonna get the reading for more easily. Now I'm gonna increase. This is for T2 for blue one, and this is for T1 for the red one. And the red one is to read for V in, and the blue one is to read for. So as I mentioned before, the one is T1 at 10A. So 498.01 milliwatt, and the T2 is at channel B, 42 second row, and this is the value is negative 487.75705 millivolt. So this is the value for V out and V in. And from this we can find the voltage gain, which is AV. So that's how to get the rate for AC and C values.